So we've just had a look at the new FuseTech models on the shoulder. What we can see is that we're able to use it as an arthroscopic model to be able to insert the trocars, cannulas and arthroscopes. It enables us to get a clear view of the articulation, including the labrum and the glenoid itself. The articular surface has a very similar feel to that of a normal articular surface in the shoulder. The labrum we can see in this model is deliberately created, so there's some tearing of the labrum, so this can be managed with a debridement, with a rasp and an elevator, and then for this to be surgically repaired with either all suture anchors or any other form of suture anchors. With regard to the biceps tendon, we can see that passing through the articulation between the supraspinatus and the subscapularis tendons to enable us to mobilize that. Biceps tenotomy and tenodesis can be performed. In this model, we've just performed surgical repair of the supraspinatus tendon. In fact, in this case, we released the tendon, debrided the greater tuberosity, and we were able to repair it using one of the suture anchors using a double row technique. From the pure concept of managing and advancing aspects of suture management, for arthroscopic rotator cuff tears, I think it adds a real lot for the doctor in training and also the experienced surgeon. We've found that this technique works very well, particularly for the subscapularis repairs as well, where we're able to use something like a bird beak or other types of arthroscopic instruments to be able to advance the torn subscapularis tendon back onto the lesser tuberosity. But it's not just as an arthroscopic model. The model is also of use with regard to open surgery. It can be used for open rotator cuff repairs, a Latarjet procedure. And I think the other place where it's really of value is there are some new models that have fractures in the proximal humerus, a 4-part fracture, which is held together by a thin periosteum. The fracture can be mobilized and enable the surgeon to learn how to plate the proximal humerus, or to be able to do reverse total shoulder arthroplasty with all the soft tissues attached. And finally, we've also used this concept in shoulder arthroplasty, where for osteoarthritis, FuseTech have developed a new model where the glenoid is retroverted of the order of 20 degrees, and this enables us to use either custom-made prostheses or using one of the wedge prostheses where it enables the base plate to be advanced onto the glenoid and then the glenosphere over the top, so that this enables those more complex cases to be made. So the idea of having a anatomic specific model so that every surgeon in the room is able to use the same model, but also to have specific pathology. So with a retroverted glenoid, it enables us to use some of the more complex arthroplasty concepts to be able to support the development of these new concepts. And finally, there are a number of computer-based systems such as the TrueMatch, and this enables us to practice in this environment, such as in the FuseTech lab, to be able to insert the prosthesis, but before that, use it on the computer modeling so that we can have patient-specific guides and instrumentation to be able to advance that on specific models, say with a retroverted glenoid. So this really does extend the surgical training opportunities, not just for the junior doctor, but also for the experienced doctor. And with more complex concepts of glenoid abnormality, this enables to teach the master surgeon, who really will have a difficult time in managing these type of problems. So it enables us to be able to provide a surgical education for the full spectrum of surgical training, from the junior registrar doctor right through to the surgeon who has a special experience in shoulder arthroplasty. Thank you. We look forward to seeing you in Adelaide, or look forward to seeing you use the new models. I think it will change the way that teaching of surgery of the shoulder is performed throughout the world. Thank you.